Hello and welcome back to in-depth Ruby course on Eduonix. My name is Ilya and this is section 2, Ruby Basics. In the first lecture of this section we are going to discuss data types. Here is the list of all data types that I wish to discuss with you, and let me open my interactive Ruby shell now, and let's start with strings. Strings can be opened with single quotes and double quotes. So here is a string with a value of high. I can define the same string with double quotes, and the difference is the double quoted strings support interpolation, and it basically means that I can go ahead and insert some Ruby code inside of those symbols here. So for example, I can say 1 plus 2, for instance, and note what happens when I press enter. This code gets evaluated and I get 3 as a result. And so inside this interpolation I can insert, well, pretty much everything. So I can define some other variable, let's call it value, type some string here, then define a new double-quoted string and say hello, the value is, and then provide my variable here. So that's it. And single quoted strings do not support interpolation, so basically I can create a single quoted string or type something like that. And as you see, as a result, I simply get the exact string. So that's, this 1 plus 2 is not getting interpolated. Also, the strings can be defined with a pretty interesting construct. Let me clear the screen now. And okay, let me define a single quoted string, but using this construct here. So I type %q and then those curly brackets, and inside of those curly brackets I can place my content. So for example test, and it is going to define a string. The same applies to double quoted string, but this time I am going to type uppercase Q and say the value is, and then say 1 plus 2, for example. And note that this gets interpolated as well. Well, this form of writing is used quite rarely, but still, well, it's useful to remember about it. Next we have integers. Integers are defined quite easily. You can say, for example, some variable's name equals to like 5. You can, of course, perform various operations, like you can summarize, you can sum your integers, you can subtract them, you can multiply them, like this, you can divide them, and so on, so working with integers is pretty easy. But note, however, that if I try to do this, I will get an error. So those types won't be converted automatically. So I cannot simply go ahead and well, apply this plus operation to an integer and a string. But what I can do, however, if well, I can try and convert manually to integer like this by saying 2i. So 2i is a method that is going to convert the string to an integer, and in this case it works. Also, there are numbers with a floating point, and so to define a float, I would say something like that. So I say 10.5, and that's a float, and all mathematical operations can be applied to floats as well. You can apply, you can say plus, like this, minus, and so on. And one thing to note is, if you try to divide an integer by an integer like this, you will still get an integer. However, well, that's not a correct result. So basically, if you divide 3 by 2, you don't get 1 obviously. So if you wish to get a result when in decimal format, you must convert one of these numbers to float. So you should say to F here to convert these to float, to a decimal number. And in this case you get 1.5, which is of course the correct result. So bear this in mind, because some new developers forget about it, and they are quite surprised when they get an integer as a result of a division. Next we have Boolean values. Specifically, there is false and there is true. We are going to discuss these values more when we will cover conditionals in Ruby, but for now, for example, we can say 5 greater than 2, and we are going to receive true as a result. And also we can say less than, and of course I am getting false, because 5 is obviously not less than 2. Another pretty interesting data type that is not found in some other programming languages is a symbol. And symbol is basically an immutable string. You can define a symbol by typing some variable and then colon, so symbols are also preceded with a colon symbol, and then the value of this symbol, something like that. And symbols are immutable. It means that you cannot change their values, and so this value stays the same until your programmer finishes its job. And actually that's a good thing, because working with symbols is rocket fast. So for example, comparison of symbols is very fast, and later we will see some use cases of symbols. So please remember about this data type. It may look a bit strange, but it is very cool. And actually if you've come from Elixir world, then you probably know symbols as atoms. Okay, the next data type is array. Array are opened with square brackets, and inside you can simply define the elements of this array, and these elements should not be of the same type. So you can, for example, mix numbers, strings. You can even nest arrays like this. You can place symbols inside, and so on, so. So arrays can basically contain anything. And now that you define this array, you can fetch any value from inside by saying your variable's name and then providing an index. For example, if I say 0 here, I'll get the value of 1. So basically arrays are indexed starting from 0. So it means that that's 0, that's 1, that's 2, that's 3, and that's 4. So they are numbered starting from 0. Also, to get this value of nested, you would type array, or then basically 3, and then 0. So that's why firstly with this 3 I access this array, and with that 0 I access this string inside, just like that. So arrays are really widespread, they are used quite extensively, so we will meet them quite often, and please remember about them as well. Next, there are hashes, and hashes are opened with curly brackets, like this. Inside you provide a pairs of keys and values. So, for example, I can say something like that, key, and then this offset arrow, and then a value, for example, 5. And note that keys and values can have different types. So, for example, a key can also be a symbol, like this. And the value can be, for example, an array. So now to access some value by its key, you can type this construct. So once again, note that I'm using square brackets here, not curly brackets, to access a value. Also, you can, of course, access a value by a symbol key, like this, and you will get this array as a result. And for example, to get this value of 2, you can say 1, like this. 1 is used because arrays are numbered starting from 0, so I want to get the second element from this array, which basically means I need to type 1 here, so I get this value of 2. Here it is. Pretty simple. Also note that it is really advised to define your keys as symbols. Why? Well, because as I said earlier, symbols are immutable, and so working with them is really fast. And well, the second benefit is that you can use a shorthand notation when writing your keys as symbols. So instead of writing this that arrow, I can remove it and type colon here and remove this colon. And so that's a perfectly valid code. So basically this construct is the same as this construct here. But the letter, I think it's just more convenient to type. So it still works. And as you see, under the hoods, interpreter still converts it to this long notation with fat arrow. So that's hashes. Next we have regular expressions, or simply regexps. Regular expressions are like patterns that describe contents of some string. So for example, you can test if some string matches some pattern. To define a regular expression, you can use forward slashes, and inside you place the actual regular expression that you'd like to create. This regular expression here simply searches for one occurrence of a letter A or B or C. Next I can define a string, type something like this, and next I can compare my string to a regular expression by using this strangely looking operator. So next I'll provide my regexp, and as a result I get 2. So why I get 2? Basically this 2 means the position where the first occurrence was found. So the first occurrence is letter A here, and that's the second position 1 because that's position 0, that's position 1, that's position 2. So basically my letter A was found at the position 2, and that's why I get 2 here as a result. I can define some other string that does not contain any of these letters. I can try to compare once again, and as you see I get nil as a result, and this nil basically means no value, so no match was found. Nil is like null in JavaScript and similar languages. We will meet nil in the following lessons as well, but for now simply remember that nil can be treated as no value. The value is not defined. And lastly we have ranges. Ranges are wrapped with round brackets, and inside you simply define your range by typing these two numbers that are separated with 2 dots. Ranges can be easily converted to arrays, for example, so if I type 2a, I get an array from 1 till 10. Also, if I type 3 dots here, it means that I want to omit 10. So I want to create a range from 1 to 10, excluding number 10, basically. So that's pretty much it. We have covered some built-in types pretty briefly, and in the next lecture of this section we will discuss conditionals in Ruby, and we will also work more with strings, with numbers, with regular expressions, so that you are going to see them in action. And so, well, stay with me and see you in the next lecture. Hello and welcome to In-Depth Ruby course on Eduonix. My name is Ilya, and in this lecture we are going to discuss conditional statements in Ruby. Let's define a very simple conditional statement by saying if for some condition, and then here you can define what to do if this condition is truthy. And inside this else branch you can define what to do if this condition is falsy. And by the way, note those sharp symbols. That basically mean that here is the comment. So that's how you can comment your code in Ruby. What I mean by saying truthy and falsy are basically the values that turn this condition to either true or false. So basically all the values are considered to be truthy except for nil and false. So those are falsy values, and all other values are considered to be truthy. So for example, even if I say if 0 then true, and here by the way I use putS method that outputs some string to a console. Here I can say false. Now let's run this program by saying Ruby conditionals, and as you see it says true. In some programming languages 0 can turn a condition to false, but in Ruby that's not the case. So 0 is considered to be true as well. But if I say nil here, then I get false as a result. So nil is a falsy value. That's it. Also, you can make this conditional statement a bit more complicated by adding else if here. Well, for example, let me create a new variable called value with a value of 5, for example, and say if value is greater than 5, we are going to say greater than, else if, and then value equals to 5. So this operator, those two equal signs means equal to some value, and we are going to say equal, and inside the else branch we are going to put the following text and say less than, something like that. And you can have as many else if branches as you wish. Now let's run this code, and we are going to get equal, of course. We can make this program a bit more dynamic by getting users input. That's quite easy to do. We can say get s, and that's a method to basically request input from the user. And we will also convert the input to an integer, because initially this is going to be a string. So even if I input a number here, that's still going to be a string internally. Let's also say enter some number, something like that. And I'm going to enter like, I don't know. And as you see, of course, I get the string of greater than 5. So that's how you can write your conditional statements. Also, instead of saying if, you can say unless. You can say unless like this, and the following string will be outputted if this condition is not truthy. So unless is quite the opposite to if. So currently if I run this code, I of course won't see any output because 5 is greater than 2, and so this string is never won't be printed out to the screen. Another thing to mention is that sometimes the conditional statements can be simplified a bit. So let's, for example, check if the entered value is odd. So this odd method is provided by Ruby for us, so we don't need to create it somehow manually. It is already there. And if the value is odd, I'm going to say basically odd. But this piece of code can be simplified, so I can cut this line of code here and place it here. And then I can remove this end, and that's it. So it works. I can try to run. So nothing is being outputted, but if I enter 5, I get this odd string. So you can write your conditions on one line like this, and there is also another shorthand notation that you can employ. So you may say if value is odd, then display a string odd, and otherwise say even like this, or you can rewrite this construct by using a special operator like this. So you are going to say value dot odd, and then you place this question mark here. And next you say what to do if this condition is truthy. Next you place colon and say what to do if this condition is falsy. So basically this and this are those pieces of code, they do pretty much the same. Now let's see some other example of using conditions. So suppose we have a hash containing information about some people. Specifically, I wish to store the age of, for example, I don't know, members of my family, for example. So I'm going to say here that mother is like, I don't know, 50, father is like 55, I don't know, sister is 20, something like that. So that's a hash that contains 3 pairs of keys and values. The keys are symbols and values are integers. And I wish to allow our user to enter some key and get the age for the corresponding person, for the corresponding member of the family. So here I am going to say enter the member of the family. Family. And here, by the way, let's say family as well. This value should be converted to symbol. So I must do this because symbols are not equal to strings. If I open interactive Ruby shell, I can check it easily. So I can say string equals to a symbol with a value of string, and as you see, they are not equal. But if here I say to sim and basically convert this string to a symbol, I will get true. So that's why here I also want to do this. And you know what, let me also say strip here. Strip is a special method that is going to strip out all trailing white spaces, all special characters like new line, and so and so and so. So if I have a string with leading spaces and trailing spaces, and then I say strip, those spaces are being basically removed. I don't need those spaces in my value. And by the way, let's name it, for example, member, not value. Let's name it member. So my member should not contain of course, any white spaces. Okay, and next let's firstly output the age for a member of a family. Okay, I'm going to run it now. I'm going to say mother and I get 50. But what happens if I enter some gibberish? Basically I get an empty string. And that's a bit strange. So the user does not understand what is happening. So why nothing is being printed out? Well, we can see what is actually being printed out by saying inspect here to understand what this object is. And as you see, this object is basically nil. And it means that if you try to access some non-existent key for a hash, nil is being returned as a result. So note that no errors are being raised and, well, the program does not crash. It simply returns nil. So we can set, I think, a very simple condition and say basically if family has key of member, then output the age. And if it does not have such key, I'm going to say I don't know. Whom are you looking for? Something like that. Note this backslash here, by the way. It means that I am escaping this single quote, because if I don't do this, Ruby will think that it closes the string, but it's not the case. So this backtick is simply a part of the string. It's not the end of the string, and so that's why I need to escape it. And another solution would be to simply use double quotes here. And in this case I don't need to escape anything. Okay, also I must use brackets here, so in many cases I can omit round brackets after the method's name, but in this case I must do this because otherwise Ruby won't understand where this statement is basically closed. And the same can be done here. And actually I can even make this code a bit more simpler by removing puts here and placing it right before my condition. Just like that. And also I think we can employ string interpolation here and say age is. And then let's test it, and as you see it says I don't know, whom are you looking for? Next I say mother, and it says age is 50, so everything is working pretty nice. Apart from if and unless statements, you also have a case statement, and it can be written like this. So you say case and then some value. I say animal, for example. And then you can say something like when, for example, cat, we say meow. When dog, we say woof. When cow, we say moo, something like that. And else, I don't know. And so we can define an animal like that. And basically this case statement can have many when branches. So for each when, you define an operation to do if this condition is met. And you have as many whens as you need. And this else is basically not mandatory, so you can omit the else branch, but it is actually required, so it's like a fallback. So it explains what to do if neither of those conditions are met. So now let me go ahead and run it, and as you see it says meow. And if I type some gibberish here, it says I don't know. So that's a case statement, and sometimes it can come in handy as well. So that's pretty much it on conditionals, and now let's proceed to the next lecture and talk about logical conditions in Ruby. So see you there. Hi and welcome back to In-Depth Ruby course on Eduonix. My name is Ilya and this is lecture 3. In the previous lecture we have discussed conditional statements in Ruby, and in this lecture I'd like to talk a bit more about logical operations and expressions. So let me guide you through logical operators available in Ruby. The first one is logical not, and it looks like an exclamation sign. So you can say not true and you will get false. Also you can say not false and you will get true. If you say not and then not again, then basically you'll get false, because those two nots they negate each other basically. Also, what's interesting, if you say not 5, then you will get false. And this is happening because 5 is the truthy value. And when we apply not to it, we get false, because this logical not, it always returns either true or false. So it always returns a Boolean value. We can also try to say not nil, and that's going to return true, because nil is a falsy value, and if we say not some falsy value, we basically get true. Well, another logical operator is equal to, so we can say 5 equal to, for example, 5, and of course we get true. But if we say 5 equal to a string of 5, we get false. But we can convert the string to an integer and get true once again. The same applies to 5 greater than or less than. Those operators were used in the previous lectures. Also we can say 5 greater than or equal to 5, or less than or equal to, and it is going to return true in both cases. Also, as you remember, we can compare a string to a regular expression like this, and as a result we either get the first position of a found match, or we basically get nil. So nil is a falsy value, so we can still use this construct in conditional statements to match some string to a regular expression. Also, you can use the following operator to say if a string is not equal to some regular expression. And what's interesting, it returns only true and false, whereas its counterpart returns either an integer or nil. Also, you can create compound logical expressions. So, for example, here I have a variable with a value of 10, and I can say a odd and a greater than 5. And as you see, it returns false. Why? Because we've specified AND here, and basically it means that the following construct is going to return true only if both parts of it return true, and as long as A is not odd, we get false as a result. This can be rewritten using this operator. So you can either say AND, or you can use those ampersands. On top of that, we can say OR, and in this case we get true, and this is happening because this logical OR is going to return true if one of these parts basically returns true. So if we get true in one of those expressions, the whole expression is going to return true. And this can be rewritten with two pipes, like this. So you either use OR word, Well, basically you use those pipe symbols. Okay. Now let's write some more code and create a method that says if a given string is a palindrome. We have not discussed creation of the methods yet, and we will do so in the next section. But for now, simply note that methods are defined with the def keyword. Then you provide the method's name, and then the arguments in those round brackets, and methods are closed with end keyword. So this question mark at the end is not required, but it simply marks that this method is going to return a Boolean value. That's, well, simply a convention shared by many developers. Okay, so we are going to create such method, and it is going to return either true or false. So for example, I can say palindrome, or then Madame, I'm Adam, something like that. And that's a palindrome because we can read this string from left to right and from right to left. And we're going to get the same result. Okay, but there are some things to note here. Because when reading the string from left to right and from right to left, we basically ignore those special characters. So we ignore this single quote, we ignore this comma, this exclamation sign, those spaces. We don't pay attention to them. And Ruby, of course, will pay attention to them by default. So I can try to do something like that. I can say string equals to, and then string reverse. Reverse is a special method that will take this string and reverse it backwards. But now, if I run this code and output the result to my console, I'm going to see false, and that's pretty obvious because this string reverse has all of those special characters, and we don't need them. We need to remove them somehow. And of course there are a bunch of ways to achieve this result, but the easiest way is to use some regular expression. So let me copy this string here and open a special website called Rubular. Rubular is a special resource that allows you to test your regular expressions quite easily. So here in this field you place your string, and here you can place the regular expression, basically. And what I want to do is I want to create a regular expression that searches for all occurrences of a non-word character. And here you can see a quick reference, and we are looking for this part, any non-word character. So let's type it here, backslash and then W, and as you see it has marked all occurrences of, so all found matches were highlighted here. And seems like that's the regular expression we are looking for. So let's create it now. For now I'm going to store it in a separate variable just for convenience. And next I'm going to create a variable called a reversed string and say string dot gsub dot reverse. So as for reverse, we have discussed this method, and gsub is yet another new method that accepts two arguments. The first argument is regular expression, and the second is the string. And the string basically says what value to use to replace all found matches. So basically all found matches with this regular expression will be replaced with an empty string. So that's a string with a length of 0. And by replacing the found matches with a string of 0 length, we basically remove those found matches. And to make sure it works, let's quickly test it inside our interactive shell. So here is our initial string. Here it is. And next I'm going to say G sub. And then, as you see, we get only our letters here, and we don't have white spaces, we don't have commas anymore, and so on, so on, so. So it means that basically everything works correctly. And the very last thing to note here is that the strings should also be downcased, because if we compare those two strings, basically they are the same, but the first string has uppercase letter and the second does not. And if I try to compare them, I'll get false. So I want to downcase a string like this, and now it says true. So the same should be done in my code. So here I say downcase. But this initial string should be modified as well. So we need to apply gsub method to it, we need to downcase it. So to avoid code duplication, let me create a new variable called normalized string and say that it equals to a string with those methods applied. Next, let's get rid of this regexp variable because it's not really required, because this regexp is very simple. Next, remove reverse string and then simply say that normalized string equals to the same string but reversed, and that this line will be returned as the result of this method. So now let's test it out, and as you see we get true as a result, and it is because we are using this logical operator here that compares those two strings, and it always returns either true or false. So that's how you can use logical expressions and logical operations in Ruby. So that's it for this lecture, and let's proceed to the next one and talk about cycles in Ruby. Hello and welcome to In-Depth Ruby course on Eduonix. My name is Ilya, and in this lecture we are going to talk about cycles. The first type of cycle that I'd like to show you is while cycle. So to define it, you'd say while then some conditions. So for example, while I is less than 5, and then basically do something. So here I can define the body of this cycle, and I can, for example, say I equals to I plus 1, and then say doing something, for example. And so now if I run it, so as you see it runs 5 times. So well, now we can iterate over some array using this while cycle. So let me define some array of 4 elements, and I'm going to say that while I is less than this array's length, then simply output the element to the screen like this. Next, once again we can say I equals to I plus 1. Of course you could say it like this, but that's a shorthand notation, and that's possible as well. And by the way, note that in Ruby you cannot say like this, so it does not work. As you see that it highlights an error here, so you cannot say I and then plus plus. It does not work in Ruby. Okay, so now let's test it out, and as you see we are getting each element. Also, of course, there is an until cycle that is going to do some job until this condition is true. So I'm going to say that do this code until I is greater than array's length. And so as you see, it runs not 4 times, it runs 5 times. And so to avoid this from happening, I need to say greater than or equal to. Why? Because array length returns 4, and so on the last iteration here I get 4 as well. And if I say simply greater than, then this cycle runs the 5th time, and I don't want this to happen because I don't have the 5th element here. And by the way, also note that it does not raise an error, it simply displays an empty string here, which basically is nil. So we can try to check that out by saying inspect, removing this equal sign, run this again, and as you see it says nil. So if you try to access some non-existent index in your array, you'll get nil as a result. And so let's say equal here, remove this inspect, and now it works as expected. But to be honest, those cycles are not used quite often in Ruby because there are many more other and more convenient cycles that I'm going to show you now. So let's create an array from 1 to 5 by using this range and saying to A, and then say array, then dot, and then each. So each is a special cycle that is available in Ruby for arrays, for hashes, and similar enumerable types. So next we are going to say do, and after this do we need to define a local variable that is going to accept a new element. So on each iteration this local variable will change its value. So for example, let's say element here. Note that it has to be wrapped with those pipelines. Next, let's say puts element and display our element using this interpolation. So this code is really expressive, and we can see right away what is happening here. So each cycle is very popular and it is used very frequently to traverse an array. Okay, now let's try to run this code, and as you see it works as expected. Well, another type of cycle that we can create is using times method. So for example, suppose I'd like to do something, I don't know, 4 times. To do that, I'm going to say 4.times and then do something. I don't know, puts high, for example. So once again, very expressive, and it works because everything in Ruby is an object. So this for is an object as well, and that's why I can call this method upon this object for. And in the next section we will talk a bit more about classes and objects and methods in Ruby, so you will see how it all applies. Okay, so let's run it, and it prints high 4 times, and moreover I can define a local variable here, call it I, for example. I can output it here, and as you see it gets iterated from 0 till 3. So iterator can also be used here. Another interesting type of a cycle is up to. So for instance I can say 1 up to 10, do once again I, for example, puts I. So this cycle will be run from 1 till 10, and on each iteration this I will receive a new value. I could also say 3 up to 10, for example. So those numbers are being output to the screen from 3 to 10. By the way, this piece of code here is called block. So that's a block starting from do to end. And the blocks can also be opened and closed with curly brackets. So this works as well. And curly brackets are usually used when the body of this block only occupies one line of code. So if your block is one liner, then you'd use curly brackets. If it occupies more than one line, you'd use do and end. So of course that's not a strict requirement, but that's well, a convention. And also to define an endless cycle, you can say loop and then do. Of course, if I run this code now, I will simply create an endless cycle, which is, well, not particularly great, obviously. So inside the cycle, you would probably want to exit this cycle on some condition. And to exit a cycle, you need to say break. And for instance, let's say break if, and then generate some random number with a maximum of 10, for instance. And if this random number is greater than 5, then we basically want to break from this cycle, to stop this cycle. Of course, this condition can be written like this, but I just want to simplify it a bit and say break if a random number up to 10 is greater than 5. So as you see, it has run for some iterations and then it ended. So that's an endless cycle for you. Hashes can also be iterated using each cycle. So for example, if I create a hash with a key and value and other key and some other value, say each, inside those pipelines I can define two local variables. So I can say key and value. So obviously on the first iteration this instance variable will get this value and this will be assigned to this variable, and so on and so on. So on each iteration those local variables will get the proper value. So we could say key is key and value is a value. So pretty obvious, like this. And notice, by the way, that the key, this key here and other key here, they are being converted to a string properly, even though that's a symbol. It is being interpolated properly without any issues. So that's how you can iterate over a hash. Another very useful method is called map. So let me create yet another array and then say map, like this. And map actually accepts a block and a local variable. I'm going to call it element. So this element will once again get values from 1 till 5 on each iteration. So map is going to iterate or this array, but it will also transform this array according to the code I am going to write inside the body of my block. So for instance, I can say element and then element is multiplied by 2, like this. So this is the return value of my block, and it is going to be placed inside this array. So effectively what I am doing is I am taking this array and creating a new array by multiplying each element by 2. So I can, for example, assign it to a new variable and then output it to the screen by using inspect, so it is printed in a bit more user-friendly way. So let's clear the screen and run this code now, and as you see, now each element is multiplied by 2. Now suppose that we have an array of some strings. So let's create an array and say inside apple, banana and cherry, for instance. And I want to display the string that is going to contain the following content. So it is going to say like element 1 is apple, element 2 is banana, and element 3 is cherry. So how I would do that? And it appears that this map method can be chained with another method that is called withIndex. So just like that, you chain this method after the map. And next you can create another local variable here, call it index, for example, but you can call it anything else. And what it's going to do is it is going to keep track of the index on each iteration properly. And now I can say element, let me do it on a separate string, on a separate line like this. So I'm going to say index +1 is element. I'm doing +1 here because arrays are 0 based, so I want to be it more user friendly, so I just say +1 so that we start our numbering from 1, not from 0. And so that's how you can keep track of your index inside this map method. So let's call it now, and as you see it works. And also, by the way, this array here can be simplified a bit, so because putting those commas, those single quotes is well, it's pretty tedious. So instead of doing this, I'm going to say percentage and then $V, and then once again apple, banana, cherry. So it is going to create an array of these strings, basically, and this whole construct will be split by those white spaces. So let's check it really quick inside interactive Ruby shell, like this. And as you see, as a result, we get this array. So that's a pretty neat trick, and it can come in handy as well. So let me run this code again, and we get the same output as before. So that's a map method that is used quite extensively as well. So this ends our quick tour of on Ruby cycles, and in the next lecture of this section I'd like to apply our knowledge in practice and create a very simple game. So we'll see you in the next lecture, and hold on tight. Hello and welcome back to In-Depth Ruby course on Eduonix. My name is Ilya and this is lecture 5, where we are going to apply the knowledge that we've received in the previous lectures in practice. And what I want to do is create a very simple game. I'm not even sure how it is called in your country, but some call it game of sticks or game of stones, but the idea is quite simple. So there are two players, and there is, well, there are like 10 stones on the table, and players take turns. On each turn, each player can take from 1 to 3 stones from the pile. And when the player who gets the last stone basically loses. So I'm pretty sure you know what this game is, maybe you've even played it. And so now we are going to try and code it using our conditions and cycles in Ruby. So I've already displayed the welcoming message here, and well, I've called it a game of stones because, well, you know, there is a Game of Thrones and we have a game of stones. And what's interesting is this piece of code here, because note what happens. I have a string with this asterisk, and I want to display it 29 times. And what I can do is I can multiply this string by this number 29. So you might think that it's not going to work, but actually it works, and it's a perfectly valid code. So that's a pretty neat trick to display some string many times on the screen. So now what we need to do is we need to ask the players to enter their names. As long as there are two players, we need to do this two times. So I'm going to say two times do something. Also, let's put iterator here and say player, then player number. Please enter your name, like this. So next I'll need to get input from the user, and also I'm going to strip all leading and trailing white spaces. But where should I store this player's name? Well, as the first version of this code, let's simply create an empty array and call it players. And so here I'll basically store the names of my players, and to put something into this array I can use this construct. You can say players and then those two angular brackets. So that's going to basically push a new element to this array, to the end of this array. And what's more, the changes will be stored in this variable. So that's going to destructively modify this receiver, this players object. So let's test it out. I'm going to output players next, say inspect our players. Next I'm going to run this code. Test 1, test 2, and as you see it works. So we get an array of two players, which is pretty nice. Okay. Now when the players have entered their names, they basically need to take turns. And how would I code this? So of course I can use some kind of an each cycle, for instance, and take each player on each iteration and then wrap this whole construct into an endless loop. So do something like this. Then players, each player, then say like player, it's your turn, something like that. And here I'm going to break off this cycle if something happens. So for example, if the number of stones on the table is less than or equal to 1 or something like that. So that's possible to do. But it appears that there is another type of the cycle that I have not presented to you yet. And this type of a cycle is basically called cycle. So here is the documentation for this method. And so what it does, it is going to call the past block basically indefinitely, so until it is interrupted somehow, until the program is stopped. So that's going to print ABC, then ABC again, ABC again and again and again forever. So that's going to create an endless loop here. So it's going to cycle over those elements over and over again. And if you say cycle 2 here, it's going to cycle over those elements only twice. And also, of course, inside this cycle you can say break. You can say break and basically finish this cycle explicitly. So I think we can use this method for our case because we want to cycle over our players. So I'm going to say players cycle do player, and say player, it is your turn now, something like that. And also, of course, I need to track the number of stones on the table, on the deck. Let's define it as a local variable. Let's say stones, and initially let's say it's 10. So there are initially 10 stones, and I can take from 1 to 3 stones from this pile. And so the player who gets the last stone basically loses. Now let's also set some condition to exit this endless cycle. I'm going to say if the number of stones equal to 0, then we are saying that this player basically lost, and then we break from this cycle. And also I think we can even say it like this. There is an interesting method that is called zero, and so we can simply say if a number of stones is zero. I think that this is looking a bit well, more expressive than saying this. It's up to you, of course. So that's how we we exit this cycle. Now obviously we need to get an input from the player asking how many stones do he wishes to take. So let's say number, something like that, and say gets, and then to I, because we want to make sure that this is an integer, because later we are going to say number of stones equals to number of stones minus this entered number here. So we must ensure that this number is an integer. So that's a first version of this program, and I think now we can go ahead and test it out. So I'll say, I don't know, Kate and John. Okay, so I'll take, I don't know, 3 stones, 2 stones, 1, 3, so and so. So as you see, it works, but unfortunately we do not check anywhere that this entered number is less than 3 and greater or equal to 1. So it should lie in the range from 1 to 3, and we do not check it yet. So let's enforce this check as well. I'm going to wrap this code in an endless loop. Why? Because basically I want to ask the player to enter this number until he enters the proper number. So here let's say if number is between 1 and 3, and this number is less than or equal to the number of stones, then break from this endless loop, and else we say please enter the correct number. So that's how basically we ensure that the user enters the proper number here. Also for for convenience, let's display the current number of stones is, and I think we can actually display it at the very top here and say just stones like this. Okay, let's test it once again. Okay, so number of stones is 10. I'm taking 3. And yeah, actually this between method, it expects 2 arguments, so we must pass them like this. So we cannot pass a range here. We need to say the minimum and maximum number here. And another thing to mention is that currently this number local variable is not visible outside of this do and block. So it will be visible inside this block, but outside this number is not visible anymore. So we need to define it here in the topmost scope like this, and say that initially this number is 0. So it should work properly now, I think. Let's run it again. I am taking 3, and the number of stones is, well, 7. I'm taking 2, then 3 again, and so now I'm, well, my turn as John. Number of stones is 1, so obviously I can take 1 stone, and so now basically Kate loses. And note what happens if I try to enter 3. It says that this number is not correct. And why? Well, because the number of stones is only 1, and obviously I cannot take 3 stones anymore, because, well, there are not enough stones, and 5 is not correct as well. So now I can enter only 1, and obviously player Kate lost. So that's how our program can look alike. Obviously it's not looking great, so we need to divide this program into individual methods. We can employ some classes maybe, and so. And in the next section of this course we are going to talk about classes in more detail, about methods, and after that we are going to refactor this program a bit and introduce individual methods for this program, because currently this is just a procedural code and it's not that easy to test. So that's it for this section about cycles and about conditions. Hopefully by now you feel a bit more confident about them, and we'll see you in the next section where we are going to talk about classes. Hold on tight and see you soon.